Okay, so here's a problem, an empirical formula problem. A compound is composed of carbon, nitrogen, and hydrogen. When 0.1156 grams of this compound is reacted with oxygen, 0.1638 grams of carbon dioxide and 0.167 grams of water are collected, and some N2 gas, which we don't know the amount of, so N2 gas. Alright, determine the empirical formula of the compound. So we've got some compound that we know contains carbon, hydrogen, and nitrogen, but we don't know how much. Okay. This compound reacts with oxygen to make carbon dioxide, water, and nitrogen. And obviously we can't balance the chemical equation because we don't know what these coefficients are. But in this case you won't need to. So we'll just go with what we do have. So we know we've got 0.1156 grams of this. 6. Looks like a 7, but it's a 1. Okay. Grams. Let's see. Does it say, nope, doesn't say O2, and we don't need it. We're going to assume the O2 is in excess. We've got, the reason we can assume that is because we're burning it. We've got 0.1638 grams of this, and we've got 0.1676 grams of water. Okay. So we would normally, we know that we can't go to moles here, and the reason is because we don't have X, Y, and Z. It's asking us to find the what number goes to carbon, hydrogen, and nitrogen, because we're looking for the empirical formula for this compound. We can go to moles here, though, and here. And the reason that we would do that, so you never want to do anything unless you have a reason for it. The reason we would go to moles here is because if we know how many moles of carbon, hydrogen, and nitrogen, and we know the ratio of their moles to each other, then we know this thing's empirical formula. So the reason we want to go to moles here for carbon is because all of the carbon in this compound ended up in carbon dioxide. Even though it's not balanced, we know that because there's no carbon in water and there's no carbon in nitrogen. So let's go to moles. We've got 0.1638 grams of carbon dioxide. Okay, for every 1 mole, nope, moles go on top, right? That's what I want. For every 1 mole, it's 44.01 grams of CO2. Okay. Grams are going to cancel out. Let's calculate how many moles that is. So 0.1638 divided by 44.01. So we've got 0.00372. Call it. Let's go ahead and write that down. So 0.00372. We'll say 2 moles. Why did I write all those decimal places? Well, because that's how many decimal places I have up here. Okay. Scrolling down here, let's do it for water now. So 0.1676 grams of water. Okay, it's 18.02 grams per mole of water. That's the molar mass. I don't know why it likes to make little connections here with the scribble tool, but we'll have to deal with it. Grams cancel out. So let's do that math. 0.1676 divided by 18.02. Alright, that's how many moles of hydrogen we have, but let's keep that number for now because sorry, that's how many moles of water we have. Let's keep that number for now though, because we want moles of hydrogen, not moles of water. So let's convert this to moles of hydrogen. For every 1 mole of water, there are 2 moles of hydrogen. Okay. So we've just got to multiply the number here by 2, right? So it's this divided by this times this. So times 2. Alright, equals 0.186. Oh, sorry, that's it. There should be a 0 here. 0.0186. Oh. Okay, and that's moles of hydrogen. This one right here is moles of carbon. This is moles of hydrogen. Alright, and if we have moles of carbon, moles of hydrogen, and moles of nitrogen, we can figure out the proportion. We can relate these to each other to figure out the empirical formula. We do not have moles of nitrogen given to us, though. So we're going to have to get to that number in a little bit of a roundabout method using conservation of mass. So the way we get that is we're going to take the mass of carbon, the mass of hydrogen, and subtract them from this mass up here to get the mass of nitrogen, and then we can convert that to moles. Okay? So we know that the total mass of this compound, the total mass, is equal to the mass of the carbon plus the mass of the hydrogen plus the mass of the nitrogen. Alright, we want to solve for the mass of the nitrogen here. So we're just going to get that by itself. So mass nitrogen equals mass total minus mass carbon minus mass hydrogen, which we'll just plug in our numbers here. 0.1156, that's not a 7, that's a 1. I don't know why it wants to do this so badly, but these are 1s. Now it looks like a 0. Not getting any better here. 0.1156 grams minus, well, we don't have the grams of carbon yet, right? So we need that. So let's convert that to grams. So this number times 12.01. Man, this is not working the way I need it to. Let's try that again. 12.01 grams per mole. Okay, so that's going to cancel that. Alright. And we're going to get, let's do the math here. Okay, so that's the grams of carbon, 0.004, sorry, 0.04470. Nope, that's a 4. Seven. Oh. Okay. These are 4s. Alright, we're going to do the same thing here, so multiply by hydrogen's molar mass. So 0.0186 times 1.01. Okay, so 0.0187. Call that 9. Okay, 9. And that's grams. I wrote that one with the mouse instead of the pen. Not looking good, but... Alright. So this minus 0, 4, 4, 7. Okay, minus 0.1879. Okay, these are both grams. Alright, let's go do that math. Okay, so that is our mass of nitrogen. So 0.0521 grams. Okay, we just have to convert this to moles now. This is mass of nitrogen times. To convert to moles, let's see. It's divided by 14.01. That's the molar mass of nitrogen. Those are going to cancel. Okay, so our moles of nitrogen are pretty similar to our moles of carbon. Three, 7, 2, 0. That's moles. Alright, so let's make a list of each of the moles that we have. So that was moles of carbon, this is moles of hydrogen, this is moles of nitrogen. So we got 0.0037 moles of carbon. Moles of nitrogen, and 0.0187 moles of hydrogen. Okay, and what we do from here I will show you in the next video.